Hello students, welcome back to OrganiChemVerse. In today's video, I'm going to explain ozonolysis by solving a question. Students, remember, more the examples, more the questions we solve, we will have a better understanding of the concept. So let's get started with today's question. How many out of the given structures gave 5 keto 2-methyl hexanal upon ozonolysis? There are two methods to solve this question. How? You can do ozonolysis of each and every molecule and check if it's going to form the product given here. Or the second method, which is most preferred in this case, is you already know the product structure. Find out the reactant structure and look for it where it is. Okay, so I'm going to explain both the methods step by step so that you can solve any ozonolysis question easily. Alright, first, what is ozonolysis? Ozonolysis is a reaction of alkenes, right? When alkenes are treated with ozone followed by zinc water in acidic medium, it's going to form carbonyl compounds, either aldehyde or ketone, depending on what groups are attached to the carbon, that is sp2 hybridized carbon. Alright, now first we will use this concept for the given molecules. How so? Look at this. The product is having one aldehyde and one ketone. That means what? The double bond should have one hydrogen and one carbon, or methyl in this case. Say in the first and second molecule, the double bond is having methyl and hydrogen. That means they may form the said product upon ozonolysis, but not the third molecule. Why so? Upon ozonolysis, you see you are going to get 2 ketone. So, not possible. Let's check the fourth molecule. This can be possible, right? But what about here? It's going to form 2 aldehyde. So this is also not a reactant. And here we are going to get a formaldehyde. Here we are getting only one product, so not possible. Same with this also. You are going to get 2 aldehyde, not possible. So how many reactant we are left with? See here, 1, 2, 3. Let's check for the first molecule, how to do the ozonolysis. You see here, there is a methyl here and methyl here. Upon ozonolysis, how to write the product? For that, I'm going to number the chain. Okay, this is not based on the UPAC rule. Students, remember this. Okay, this is just for our sake, how to write the products, right? So look at this. We are going to get a longest chain with 6 carbons. So I'm going to write 6 carbon. At second position, the ketone is formed. At fourth position, so where is the fourth position? 1, 2, 3, 4. And at the sixth position, aldehyde is formed. Now, whatever the name is given here, that is based on UPAC. So therefore, let's give aldehyde give priority over, it gets priority over ketone. So 1, 2, 3, 4, 5, 6. 5 keto, that is correct, but look at this. This is 3 methyl, whereas here it's 2 methyl. So this cannot be our reactant. Let's check the second molecule. Are these two same molecules? I don't think so. Right? Because when we number it from the double bond, 1, 2, 3, it is 1, 3. What about here? 1, 2, 3, 4. This is 1, 4 dimethyl, right? Therefore, they are kind of positional isomers. So definitely they are going to give 2 different products, right? So maybe the second one might be our correct reactant. So anyway, we will verify. Right? So the double bond is here. Do the ozonolysis. Of course, it's going to form 6 carbons, right, in the longest chain. I will write that also. But when I start numbering from here, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Here, this is where the methyl will be positioned. That means what? When I number it, right, you don't have to give the full UPAC name. Just check where is the methyl. At second position, 2-methyl. Yes, that is our reactant. Now let's compare the structure with the fourth molecule, like how we did here. Let's compare here. So if I number from here, 1, 2, 3, 1, 3 dimethyl. This is also 1, 3 dimethyl. That means this and this molecule, they are identical. So we have already ruled out the other molecules. Just now we have ruled out this molecule also. Left is the second and the fourth molecule, and they are identical. Hence, among the given molecules, there are only two structures, right? They are asking structures, not two different molecules, okay? They are the same molecules, right? So these are the two structures which are going to give the product set here, okay? Then let's move to the second method. That is easy way, okay? First, you need to write the structure of this product. 5-keto 2-methyl hexanal. First, we will write hexanal, right? 1, 2, 3, 4, 5. 5-keto. And at second position, there is a methyl. How to write a reactant? This is called retro method. Retro means you know the product, you are predicting the reactant. See here, the bond formation is between first and fifth. That means it has to be a 5-membered ring. So if I take this as first and this as fifth, right, the bond is formed here. And at second position, there is a methyl like this. Between first and fifth, there will be a double bond also. Only then you can do ozonolysis, isn't it? And at fifth position, there is one more methyl like this. Now let's give the UPAC name for the reactant, right? So what is the UPAC name? 1, 2, 3. So 1, 3 dimethyl cyclopentene. And where do we have it? Here. 1, 3 dimethyl cyclopentene. 1, 3 dimethyl cyclopentene. So one product, one reactant. Its structures are given slightly different, but they are one are the same. Therefore, among the given structures, there are two molecules or two structures which will give the final product given here. Or you do the retro method, look for the molecule where it is. I hope I made this concept clear to you, and if you still have any queries based on ozonolysis or any other concept, you can post them under the comment section. Thank you for watching this video.